Hello, hi everybody, this is the Happymath channel. In this video, I want to share with you another technique to calculate the antiderivative or antidifferentiation. This technique is very useful for the general integration and integration by parts. You already know about the power derivatives. For example, d of h power to n will equal to n times with h power to n minus 1 times with dx. So this formula to calculate the antiderivative. And the antiderivative formula or the rule of the integrating is h power to n times with dx will equal to d of h power to n plus 1 over n plus 1. For example, in this technique, I call this outside and in our derivative. I call this in our derivative. For example, when I have derivative of h4, h power to 4, so the main function in our main function is h power to 4, and it is the right of the derivative. It means it is right of d, and I want to change from left to the right, so I have to change the main function. It will become to 4 times with h power to n power to 3 times with dx. So from this one, the main function is 4 times with h power to 3, and this main function is the left of the dx. It means it is the left of the derivative. I call this technique in and out technique. When the main function is the right of the derivative, it is in the derivative, and when it comes to the left of the derivative, it is out derivative. So when you want to move back from the main function from the left, to move it to the right, you have to change from main function equal to h4. For example, when you got h times with 4 times with h power to 3 times with dx, it will be equal to d of h power to 4. And another way, h power to 5 times with dx. So apply this one, apply this formula, you will got that d of h power to 5 plus 1 and over the same number pi plus 1, and this will come equal to h power to 4 over to h power to 6 over to 6. Okay, so the key point, the most important point here is the number of the term here is have to be the same as the number of this one, and it is the key of the in-out derivative. Let me take some example. When I want to calculate 2h power to 3 times with dx. For example, when I calculate when I want to calculate the derivative of the h power to 6 times with dx, it means I have to move the main function from the left of the derivative become to the right of the derivative. I have to apply this formula, and main function h power to 6 will become equal to d of h power to 7 over the same number. It's 7. Okay, the main as I say, the main point here is the number, the key point, the number of this term have to be equal to this term. And when I change h 2x power to 4 times with 2x, so I want to move the main function from the left come to the right, you can change d 2x power to 5 and over 5, the same number with the power number. Yes, and another way, 3x minus 2 and time of d of 3x minus 2. This is power to 4. Okay, the main function, this is equal to the main function, this is, and it will become to d of 3x minus 2 power to 5 and over 5. Yes, this term have to be equal to this term. Yeah, that is the key point. So change to the harder exercise. You will got some another exercise like this to apply this one. Okay. In the first one, very easy to apply that. So you got 4 either outside and h power to 3 when moved from outside the derivative become to the inside of the derivative. It will be changed the h power to 4 over 4. It means d of 4 h power to 4 over 4 and it will become equal to h power to 4. For the number 4 is a constant number here, time with dx, so you can change the position from outside become to inside of the derivative. It doesn't change anything of the calculation. From this one, another way to calculate, you see that the outside function here is 3x, but the inside function is only x. So I have to change from x here, it has to become the 3x. By this way, I time with 3. So when I time with 3, I have to cancel 3 by divide it by 3. So from this one, I will got that 1 over 3 outside time with dx. Okay, so the main function equal to the main function. The out function, the out function equal to the in function. I can apply this one. In this case, the power number is 1, so it had to be changed become the 2. Over the same number. Okay, and now I move from the I move constant number from outside the derivative become to the inside of the derivative. And you will got this result of the anti-differentiation of this function. Okay, I hope you can understand. And one more step about another exercise. Square root of the 3x plus 5. The main function, you can change the square root become to the power number, and the power number when it is 1 over 2 times with dx. The main function you got here is 3x plus 5. The inside function is only x, so I should change the main function. The in derivative function, it becomes to the 3x plus 5. So first one, I have to change from the x become to 3x. I multiply by 3. And of course, you have to divide by 3 to cancel. And the next step, you have to change from the 3x have to become to the 3 plus 5. So when you plus or minus a constant number of the derivative, it doesn't change. The same number, this one have to be equal to this one, because the derivative of the constant number, for example, is c, will become to a. C is stand for by constant number. Okay, and now apply this formula. You will got that when the outside function becomes to the inside function, you got the derivative of 3x plus 5, and the number power is 1 over 2 plus 1 is mean 3 over 2, and it had to be divided by the same number. Divide by 3 over 2 is mean you have to time with the 2 over 3, so time with 2 over 3 is mean like this. Okay, and the final result is 2 over 9 times with d 3x plus 5 power to 3 over 2. Okay. One more step. Okay, in the same way, first step I have to change from dx become to the 3x. Oh no, we don't need to 3 more. It is 4. So I have to time with 1 over 4 outside. Because I will change from dx become to the d of 4x. And immediately I plot 5. So the outside function becomes equal to the inside function. So apply this one, I will have and derivative, total derivative of this function is 24. Okay, that's why I want to call this technique in or out derivative. Outside function, when you take the anti-differentiation, it will move to the inside function of the derivative. From the left of the derivative, we come to the right of the derivative. But the key point here is you have to set up the term like this, have to be equal together, exactly equal together. Okay, this is the first video about the anti-differentiation. So if you have some comment or you have some problem this one, just tell me by the comment in the below of this function this video. So subscribe if you like this. Thank you so much.